So before we begin, let's quickly recap what we discussed in the last lesson. So we talked about what is a product catalog, some of the different things that we want to put into our catalog and the different makeups. What are the different parts of the catalog, such as our products, the vendors, the category types, and images. And we talked about the differences of the relationships between our products and vendors, the products and the images and the categories and the products. Today, we're going to cover the different types of applications we can use to store data, to edit our product data. We're going to look at the different types of data files. There are many different types of data files out there besides databases and spreadsheets. We'll get into some of the more common data files that you will probably encounter either through transmissions from vendors if you're trying to pull down some of their product information from their sites. They're merging product catalogs from different companies into one. So we'll look at those different types there. Then we're also going to walk through how to use the applications to create the data files and edit or even view and search some of these data files. And finally, we're going to look at using a database to build our catalog. At the end of the day, our product catalog that we're working to build is going to be in the database, and everything we're going to work on after this lesson will be database centric. However, you really need to know that all these pieces that we're going to talk about today, the applications, the different types of data files, because yes, we are building a specific product catalog for a specific need. However, your need may differ from my need. So I'm building this product catalog for my Doctor Who website, whereas you might be building a different type of product catalog or even a customer catalog where you might want to store your customer information. So there are many different types of file types that we can use, or different catalog types. So some of the applications we can use to store data. We've got our plain old text editor. This could be Notepad. This could be Notepad++, text edit, or you could even go old school Vi or Vim. Spreadsheets. Microsoft Excel has been around for years. It kind of is the de facto go-to spreadsheet for most companies. Numbers is the Mac equivalent, or more commonly, a lot of people are now using Google Sheets or the Google Docs application suite within their Gmail accounts. Google Sheets is actually pretty good, but not real great for offline use. So you would either be sticking with probably Microsoft Excel, Numbers, or another one, which is OpenOffice, which is a open source equivalent to Microsoft Excel. And finally, we have our database. And the database, we could look at using things like MySQL, SQLite, which are both open source database solutions, or Microsoft SQL Server, which is a paid licensed server. You could also go get Oracle database. There are other databases out there like Postgres. So these are just three specific ones that are the most common that I've run across in the last few months. For this particular course, we will focus on the MySQL when we get down to that section. So what are the most common types of data files? Well, for those of us that are really old and deal with old school systems a lot, we have fixed length files. We also have delimited files, commonly known as CVS files. We have XML, which is more commonly used for web type of transmissions and passing data across the web. We also have JSON, which is another type of data format and data file that gets transmitted or used for passing large amounts of information. Very commonly used for catalogs, such as product catalogs and customer catalogs. And XLS, which is a spreadsheet, Microsoft spreadsheet format, most commonly used by most companies. And even if you're not using Microsoft Excel, most spreadsheet applications do have a way of saving the files into the Microsoft XLS format. So let's dig into the details of each of these file types, starting with the fixed width data file. So a fixed width file is a file that has a specific format which allows for saving of textual information or data in an organized fashion. In plain terms, you are saving your product information on a row and you have fixed column widths. So those rules for creating the fixed width file for those columns, each row contains one complete record of information. So each row in our fixed width file is going to be a complete product, all the information for one product. Our text is going to be arranged in rows and columns. So products going across for the row, and the columns are going to be the individual fields for our product. Each column has a fixed width, which determines the maximum amount of data it can contain. So if your width is set for 50, say for product name, you won't be able to put a product name in there greater than 50. If you do, you're going to mess up the fixed width file format, and any application or system that you send that file into will break. And because we're using a fixed width file where all of our columns are fixed, you don't need to worry about delimiters. So this removes the potential problem of putting in special characters like commas or pipe delimiters to divvy up your data or your fields, which can be a problem if that field contains a comma. So like our product description, if it contains quotes, commas, semicolons, if we actually use one of those delimiters to separate these fields, it could cause a problem, either by the application reading it or by parsing the file into a database or just trying to read the file itself. And the other rule, which is crucial, is the fields must be left or right aligned. Empty spaces must be padded on either side. So if the field is left justified and your product name is 10, but your product name field is 50, you're going to have to put another 40 characters after product name before you add the product description. So this could be spaces, it could be underscores, it could be anything, but it has to be filled. Same goes if you right align it. So if you right align product name and product name is 10 characters, you're going to have to precede the product name with 40 either empty spaces or some type of character. So if we were to build a fixed width file, let's look at some of the properties for defining our fixed widths. So for this example, and for most of the file type examples, I'm going to be picking on products. We have 4 areas of the product catalog we're going to be talking about, but for the file types, I'm sticking to products. When we get to the database, we'll expand that into each of the different focus areas like vendor, images, and category. But for now, we're just going to focus on product. So here, we've identified our product from the previous lesson of having a product ID, a product name, a product summary, a product description, a product price, and quantity on hand. So that gives us 6 columns. Now, the other thing, because we're dealing with fixed file, and actually it becomes useful for database and some of the other file types, is the number of characters allowed for our columns, for our fields. So product ID, let's say we need 5 characters. Alignment, most numeric fields tend to be right justified, so we'll right justify it. We'll also prefix the numbers with 0, so we will pad it with 0. So if we're 1, it'll be 0, 0, 0, 0, 1. The second column will be product name. We will make it 20 characters. We will left align it because most alphanumeric fields are left justified. And just for this example, so that you can actually see the padding, we're going to use the pound sign for our padding for all alphanumeric. For all decimal, we're going to use 0. So for product name, product summary, and product description, we're going to postfix those fields, those data for those columns with pound signs. So for column 3, for product summary, we're going to set the number of characters to 50. Again, left justify. It's alphanumeric. Product description, column 4, we're going to set that to 500 characters. Again, left justify, padding pound. Column 5, product price. So this one's slightly different. Since price is actually a dollar amount, we're going to set it to be number of characters 6, but we're going to right justify it, pad it with zeros, and we're going to make it a data type of decimal. That means that we're going to have some decimals. We'll get more into that later as we get down into the database, because there's some specific formatting that you want to do for your characters. But for now, we're just going to set the column width to 6. If we assume decimal, that means we're going to get 3 positions on the left. So none of our products will be over 100 or $999. Decimal period, and then 2 positions to the right for the decimal. And then lastly, we have column 6, number of characters, 5. This is quantity on hand. So that's going to give us up to 99, 1, 2, 3, 4, yeah, 99,999 quantity. And if you have that many items, great. Doubt you'll have that many unless you're dealing in screws or needles or something very small with large quantities. Again, right justified, numeric, and we're going to pre-pad it with zeros. So let's take a look at what it looks like. So when you're actually looking at the file, so this is an example of an actual fixed width file. So for the first line, I've actually put it in the column or the column headers. So we have ID, product name, product summary, description, and it goes on all the way out till we hit quantity. As you can see here, we have prefixed the ID with the leading zeros, 1, 2, 3, 4, 5. And then as you can read it, so we have product 1, 2, 3, 4, 5, pretty easy to read straight down. Product summary, this would be all of our product summaries, and then our descriptions and so forth. Any questions on fixed width files at this point?
I got a question for you. What do you mean by padding?
The padding is either prefixing the data in the field to meet the width conditions of the column. So our product ID, the column was 5, but since my ID is 1, I have to put 4 zeros in front of the 1.
Okay, so the 4 zeros is like the padding, isn't it?
That's the padding. So if we go back, so you see for product name, the padding is the pound sign. Product name is supposed to be 20 characters. So I actually put in product name of product 1, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I put 9 pound signs after that to meet the condition of the width of 20. So product name is 20 characters long.
Okay. All right. That makes sense.
So we'll jump into what is a CVS data file. CVS data files are the basic idea is of separating fields with a delimiter such as a comma, semicolon, any type of special character. You could use a character like an alphanumeric character, but that's highly discouraged. It really should be a character, some type of special character that is not used in common text or sentences or even in descriptions. That's because when you create the CVS file, you want to use the delimiter to separate the fields. So again, this could be the comma, the semicolon, or the pipe. But you got to watch out for the field data that may also contain the delimiter or even embedded line breaks. In these cases, you want to use quotation marks to surround the fields. But again, you can run into problems if the data in your field actually contains quotation marks. So you may have to either alter the quotation marks inside your data or strip them out or find some rule or some type of tool that will help you create the file or strip the data. This is a huge problem with CVS files, especially with older databases where they allowed quotes, semicolons, and commas in fields. But when you're dealing with comment blocks, like on a web page, those can contain commas and other characters. So typically you want to look for things like maybe pipes, stay away from like parentheses, percentages, maybe use the what's it, shift 6, which is the little caret. So just kind of look at your data before you pick your delimiter. Just don't go randomly pick comma because you might end up in trouble. And then if the field does contain the embedded question marks, the CVS implementation may need to include escape characters or escape sequences. So what it means by escape characters or escape sequences, based on the system that you're pulling it from or putting it into, you may have to translate that quote into an escape sequence like and like quote if it was HTML. All right, Rob just pointed out a little typo on the slides, so my dyslexia wins again. In the places where you saw CVS, it actually should be CSV.
For comma separated values.
Instead of CVS. So I'll update the slides when I export this out, but just for the slides we've already gone through, just remember it's actually CSV, not CVS. All right, now let's look at an example of what a CSV file looks like. So a CSV file looks different than our fixed width file. In this case, we are using quotes around our fields, around our column headers, and around our data. And in this particular case, I went ahead and used comma for our delimiter. So as you can see, we have the quotes, we have the commas. Now, because I actually use data that is pretty easy to read, it all lines up pretty nicely. Unfortunately, this really is not the norm. In a lot of cases, you will have data that goes all over the place, so that it really doesn't line up, and it's not really easy to read if you just look at the file directly. It is easier to read if you import the CSV file into a spreadsheet or some type of editor that can read and format CSV files. Any questions on CSV files before we move on? All right, next, let's look at using a text editor for building our fixed length files and CVS files. So let's edit out of the presentation for a minute and go to a text editor. So I like using Text Wrangler, but any old editor will do, Notepad, Notepad++, and so on. So let's go find this a product. So we will go to Dr. Who's stuff. It's my Dr. Who sites where my catalogs live. All right, so this one, right off the bat, we'll do product ID. We know it's got to be 5 characters, so 1, 2, 3, 4, 5. My product name is a device of death. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Just put a placeholder there. And it's going to be name, description, and we are just going to assume that's 500. One little trick when dealing with fixed length files 1, 2, 3, 4, 5, is actually putting a little cheat sheet at the top. So I typically do numbers 0 for first column, 1 increment up, so I did 10. So you kind of see the limitations or the problems of doing a fixed length file. You got to be very careful on how long your fields are. But what you do is, so this is just an example. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I cut it a little early, but then we come over here, and then we have the price, which is going to be $60, 60, but that's 5, so precede it with a 6, 2, 3, 4, 5, 6, and then we have quantity on hand. So 1, 2, 3, 4, 5, which will be 1, 2, 3, 4, and we'll say we have 1 on hand. So following this format, we then just go down 2, 3, 4, 5. So we now had 5 products. So 2, 3, 4, 5. And we'll add the description here. I'm not going to go through all these, but I just want to do a couple so you can kind of get a feel for how this works. As you notice, I have to add spaces in to make sure everything lines up. And that's essentially the benefit of the fixed width over the CSV file, where the CSV file, you can put in as many things as you want, and you don't have to worry about the width. You just have to make sure that you have the same number of fields in a delimited file. So essentially, as you scroll down, you're going to get the different values. So this would be 30, 44, 11, 97. So you kind of get the idea. So as you look at the file now, we'll expand this, you can read the data top to bottom, left to right, and you really don't have any problem identifying what the data is. So like here, I would put price, and since price just happens to fit within the size, that works. And then we have quantity, and then description. Now, if you don't have the header file, you're going to have to also provide the details or the formatting of your fixed width file. So kind of like what we had in the slide here. So you would have to provide some type of documentation with the fixed width format. Now the comma delimited file, we essentially drop all the prefixes, and you just wrap it in your delimiter. Now this is a longhand way of doing it. You can generate the CSV files from a spreadsheet, and when we cover the spreadsheet, I'll show you how to do that as well. But now as you look through this comma delimited, you can see it's a little bit harder to read. It's not really lining up correctly. So depending upon how your data is, it's going to be very hard to pull out what data is what without parsing the file first. But as you can see, it's very easy to do this in the text editor. It just takes a little bit of time, a little bit of work, and it's real quick. You just start typing a format. But it's really problematic when it comes to typos, and it's not very forgiving because there's no way to validate your data. Jumping back in, let's look at what is an XML file. So an XML file stands for Extensible Markup Language. It is syntactically similar to HTML, meaning it's got a DOM-like structure of tags in open and closed tags like HTML. It was designed to describe data. It is also a World Wide Web Consortium, or W3C standard, that lets you create your own tags. And it uses a DTD, document type definition, to formally describe the data. So similar to what we did here for building our fixed-list file, the DTD is going to be a XML definition of the XML files. So it's going to contain this type of information. So here's an example of the DTD for products. So this is similar to how we defined our columns for fixed width, except this time we're defining our tag definition. So at the top level, we have products. So products is going to be the overlying parent tag surrounding all of our products. Inside of products, we're going to have a product, which is going to contain an ID, our name, our summary, our description, our price, and quantity. And then beneath that, we're defining each of the element IDs and giving it a PC data type. I'm not going to get into the intricacies and details of XML. We'll cover that at another time. But for this particular example, I'm just mainly walking through the highlights of XML and creating your product catalog in an XML file. So now that we have our DTD, we can build our XML file. So here at the top level is our products tag, and at the ending is our products tag. Because it's plural, it means it contains multiple singular groupings of products. So we have products, we have a product group here with ID, name, summary, description, price, and quantity. And then we put our data fields inside of those tags. So they are always in between an open and closed tag. So we have product 1, product 2, product 3, and product 4. So let's go look at some tools for building XML files. So there is a slew of tools out there, but we're going to use Eclipse for a lot of these examples because Eclipse has a lot of built-in tools and a lot of good validation tools built into it to help you mitigate any typos or problems you have with your code. So I copied the data from our slides over into this file here called product XML. An XML file has to start with this opening tag XML version in the encoding. Our DTD definition, this could be in a separate file, but for this example, it can be embedded within the XML itself. Again, this is just kind of describing how our XML file is put together. So we are going to have a product with a subset of these tags here: ID, name, summary, description, price, quantity. Again, products and all the way down. What's nice about using Eclipse for this is Eclipse also has an outline tab here. And within the outline tab, you can expand out and see all your fields here. And what's cool about it is you can also add another product. So you can go in here and kind of manipulate your products. So as you see here, that product it just added, it just put in the tag IDs for the details. So you then just go in and edit the details. So if you want to add multiple products, you can add them there. If you want to just jump around, you can use just clicking over here jumps you up and down through the editor. Now, another cool tool, and it's called Edit X, and there's a free version, a trial version. There's a couple other open source tools, but this one's kind of cool, and it's similar to what most of the tools have. But we load our product XML file. Again, we have our DTD information at the top. We have our product information. And what's neat here is you have again, you can expand out your tree, but here you can also get to the text. And one of the big benefits of using XML is you can use XQuery or XSLT query and actually search through the tag information. So what this actually provides, which is kind of cool, is I can type in search, let's say $49.99, hit enter, and it can search the elements for the value of $49.99. Now it's looking for the exact value, and then it will give you all the IDs where it finds that text. As you can see, oops, I forgot to put the $ in front of this one, so I can add the $ now, save my file. So there's a lot of different tools like this where you can actually go out and query and look at your data, because these files, if your product catalog is done correctly, and over time, these catalogs are going to grow. They're going to get large. Unless you have a very small company with only maybe 100 products, then sure, looking at the file may be beneficial. Otherwise, you're going to need tools like this to actually go through the larger catalogs and find your information. Jumping back in. Next, we have JSON. JSON stands for JavaScript Object Notation. It's a lightweight data interchange format. There's another one, which is JSON, which is becoming more and more familiar as the Google libraries and Google tools get out there a little bit more. But JSON tends to be more of a standard that you'll see more often than not. It's easy for humans to read and write, easy for machines to parse and generate. It's based on a subset of JavaScript, so it's very easily compatible with web pages and web. And it's typically built with two structures in mind. One being a collection of name value pairs, and the other just being an ordered list of values. So if we go back and we use our fixed width format to get our product descriptions, so we have our ID, we have our names, our summary, our descriptions, and our price. This kind of looks like a CSV file, except it's not, because you have the key value pairs in every single record, in every single row for the product. So we have our products, and each line indicates a different product. Start and end with squiggles. When you want to do a subset or an array, you open it with a square bracket. I'm not going to get into too much detail as to the formatting, but this is essentially how the JSON file looks. And again, we'll jump back out to Eclipse here and take a look at that. There it is. So here, unfortunately, I have not found too many useful JSON generating tools. So a text editor is typically the way you're going to have to go. But the reason I like Eclipse is because it highlights your coloring when you create a JSON file. So it highlights your keys, it highlights your values, it highlights your definition IDs. It also does give you the outline view, so you can expand out the tree and actually look and see how your data is being read. So if you mess up, you'll get an error. It'll tell you something's wrong. So like if I leave that off and try to save it, it gives you a little red X saying, hey, expected valid string character at the end. So you add the string character, and then save it, and it goes away. Or if you leave off the squiggly bracket, hey, multiple markers, it can't find the closing bracket. So it's one of the useful things why I like using Eclipse over a plain text editor. For those of you that are not developers, you can download the plain vanilla version of Eclipse and just install the plugins as needed. If you're a Windows user, I recommend looking at Notepad++. They have similar plugins for validation and syntax coloring like Eclipse does, but it's a little more lightweight than Eclipse. Next, we're going to look at our XLS files. XLS, as I said before, is a file extension for a spreadsheet file created by Microsoft Excel. XLS stands for Excel spreadsheet. So now we're going to jump out and we're going to build a workbook in Excel for our product catalog. So we have our workbook. Spreadsheet is built, basically your core spreadsheet is a workbook containing multiple sheets. So for our particular product catalog, we could set up one sheet being product, one being images, one being vendor, and category. So we're just going to stick to product. So our column header will be ID, product name, summary, description, price, and quantity. So we have 1, 2, 3, 4, 5, 6. We'll just say product 1. Two, 3, 4, 5, 6. 3, 1. 2. Oops. 3, 4, 5, 6. Some product details. And we'll say $10, $11. So if you notice right off the bat, alphanumeric, left justified, numbers, right justified. So it kind of follows the typical data format across platforms. That's typically numbers, right, text, alphanumeric, left. 15, 15, and then we'll just stick 1, 2, 3, 4, 5, 6. We'll save it. Products. Now our products, if we actually were to go look at, to try to open this guy up in editor, there it is. And it's not really going to read it because it's not a straight up ANSI file. It's a bit of a binary. You can open it up and you'll see a bunch of Microsoft syntax, kind of XML-like in nature, XSTL or XSLT, but you really don't want to try to manipulate an XLS file that way. You want to do it within the Microsoft Excel or within some type of spreadsheet tool. Now, the other thing you can do, which is kind of cool, is you can export. File save as. There we are. So in your save format, there's your CVS file. So if you want to create a CSV file from your spreadsheet, you can do it this way. And then you have other options, so you can password protect it, and we'll save it to our same location. Save active sheet. So that's something else. CSV files are sheet specific. They're not workbook specific, so it's per worksheet. So if we go look at our product, just use gedit. I have lots of editors, but they all are basic editors. So as you can see in the editor, it just put the comma delimited files out as is. If you notice, there's no quotes around the CSV file. If you want to do quotes around the CSV file, you're going to have to add some additional settings when you go to export it from Excel. But you can export a CSV file, you can import a CSV file into Excel as well. So if I do, you can import them, but it's sometimes easier to just open it. So by double clicking it, it opens it and it will delimit it for you. If you're dealing with other delimiters other than commas, sometimes it'll ask you to select the delimiter, or it'll load all your data into the first column. If that happens, then you just go to data, select the column, and do text to columns, and then there you specify what the delimiter is, and there you can change it to semicolon, comma, space, or other, in which case it could be pipe. So next we have databases. So database is essentially, from the dictionary, it describes a database as a comprehensive collection of related data organized for convenient access, generally in a computer. So why should we use a database for our product catalogs? Why, now that we've looked at all the file types, we've looked at fixed width, CSV, XLS, why do we want to use a database versus just a plain old file? Well, it's easy. It's a lot easier to organize your data into rows, columns, and tables. In a database, essentially your workbook becomes your workbook becomes the database, your sheets become the tables, and then the row and columns are essentially the data sheets being translated into rows and columns. Index your data to make it easier to find relevant information. Well, you can search through a spreadsheet. As you add more and more data to a spreadsheet, your system will start slowing down. The more data you have loaded in memory, such as a spreadsheet, some machines have a hard time processing that unless you have a beefy machine with lots of memory. Once you start getting over 10,000 or even 5,000 rows, spreadsheets typically are not the way to go, as they will be unresponsive or perform poorly. Whereas a database, by indexing your data, it's a lot easier and a lot faster to search through a database to find information. You can also quickly add, update, and delete data as new information is added. Data can be easily queried for reporting. You can run applications against them. So how do you build a database? Well, for our examples, most of the SQL scripts that we're going to show you, SQL, by the way, is the common scripting languages for databases, with the exception of Oracle and maybe DB2. Most of the scripts we'll show you today will work on any database. If they don't, you'll just have to look up in the database manual to see what alternative syntax or command is required. For the most part, typically it's either a single quote or a double quote that's required from what we're using here. So to build a database, we want to create a database called catalog using the create database product catalog command. This will go in and it will create a catalog database in your database environment. Again, for us, we're going to be using MySQL. Creating a database that already exists will return an error However, if you are trying to create a new catalog and get rid of the old one, you can simply remove it by using drop database and the database name. So if we had a product catalog out there and we messed it up and we need to start over, you can do drop database product underscore catalog. Be very careful using the drop command. If you don't want to drop or delete your catalog, don't use that command. But if you do, but you still think you may need the data, back up your existing database first, then drop the database. So the database is essentially our workbook. So we've now essentially built our database for our product catalog. So what goes into our database? Well, we need to add some tables. Well, before we do that, let's go back and look at what we said about product catalogs. What do we need to put into our product catalog? Well, we need a product, we need a category, we need some images, and we need some vendor information. So now these essentially become our tables. So let's look at product first. So product, we've identified as needing an ID, a name, a summary, a description, a price, and quantity on hand. We've also defined the properties, or most of the information for the database properties, back when we defined our fixed with properties. When dealing with the database, there's some additional fields that, or additional information you need for each of your columns. So we still need to know what column number we're dealing with. We still need to know the character lengths. An additional field is primary key. This is the unique key for your table that will index your product information or your row information. So it's going to be a unique value. Typically, you will have one primary key on most tables. In some cases, you may have two primary keys or a composite key, a combination of two keys. Next, we have default value. So for our primary key, not all databases have some type of auto incrementing feature or setting that you can set that when set and you're dealing with a primary key, every time you add a record to this table, it will automatically add the next unique ID in the sequence to the table. So once we add the first product is product 1. When we add the second product, it will increment it to be product 2. Down at product price, we've set our default value to be 0.00. So even if they don't set a price, we still want to default it to 0. Same for quantity on hand. If there are no products in stock, we want to set it to 0. The next value that's new is can the value be null? Can this column value be null? For product ID, for your primary key, it will never be null. Your product IDs or your primary key values, I should say, the systems will not let you set that null. If you try to set it null, it will fail. Also, it needs to be numeric. Other values that we need in our product table that probably should not be null, just to prevent inconsistencies, is a product name and product summary. Again, we're defaulting product price and quantity on hand, so even if they don't enter those values, those will be set to 0. The only value in this particular table that could be null could be product description. Maybe we don't have one. But we do want to make sure that every product has a name and some type of brief summary describing a little more detailed than the product name, because the product name could be truncated. So the command to create the product table is create table. So because we've created our database name as product catalog, we do create table. This is not apostrophe, it's the back apostrophe, product underscore catalog dot product. So our table name is going to be product. And the table is going to contain a product underscore ID. ID is acceptable, but you really want to keep your IDs descriptive to the table. So if you did not name your table too long, the table name underscore ID is typically kind of the de facto primary key name for your table. And we have name, summary, description, price, and quantity. Integers in MySQL are described as int, and alphanumeric is varchar. And as you can see, the varchars, we have to define our character lengths. Integers fall into a different category, as an integer has a set max character with which is a very large number that we will probably never have to deal with or hit within our system. I do see one little mistake. Let me fix that here. So instead of price being varchar, that was actually supposed to be decimal. 8 and 2. All right, so for describing decimals in a system, it's a value called, or it's the syntax used is decimal. For our values that are not null, we use the command not null. If we want it null, we drop the not and just leave it null. And if you want to add default values, you add default to your column descriptor as well. For our product ID, which is also our primary key, we can add auto increment. Again, this is not in all databases. Most databases have some type of auto increment function. In our case, thankfully, MySQL does, so we're going to go with it. And we set our primary key to be our product ID. All right. Now we're going to jump into the basic components of a category. So previously, we mentioned that we need a category ID, a category name, and a parent category ID. The parent category ID can be blank if this particular category is a parent category. But if the category is a child or a subcategory of another category, then it will contain a parent category ID. Properties for category we have here. So again, create table, database name, table name, your column IDs, int, varchar, int, not nullable, not nullable, not nullable, auto increment, and primary key. You're going to start to see a pattern form with create table. This is pretty much the typical structure you will see for creating tables. Our image, so we have image ID, name, height, width, type, and location. And we define these as such. Again, looks very similar to how we did product and category. These were our basic components of a vendor. So for vendor, we're trying to capture the basic vendor information. So here's the command to create our vendor. So now let's talk about some relationships. So a recap of what a relationship was for our product catalog. It's a context of our product catalog. It's a situation that exists between two components where one component has a way to reference the property of another component and vice versa. So the relationship types were one-to-one, one-to-many, many-to-many. In one-to-one, a row in a table can have no more than one matching row in another table. So we have table A and table B and vice versa. So a one-to-one relationship is created if both of the related columns are primary keys or have unique constraints. So for example, our product and image. So we assume a product has an image, only one image belongs to one product and vice versa. Hence the one-to-many relationship between the tables. So by adding product ID to image, we now have a one-to-one relationship between an image and a product. If we want to query that information, we run the query select product.star grabs all columns, comma image.star, which grabs all the image columns from product, comma image for our tables, where product.product ID equal image.image ID. So that ties the product ID from both tables to get one record if the record exists. One-to-many is a relationship that is the most common kind of relationship. In this kind of relationship, a row in table A can have many matching rows in table B, but a row in table B can only have one matching row in table A. Such as a category can have multiple products, but a product can have one category. So in this instance, many products belong to one category, therefore we add the field category ID to the products table and perform a table join on product.category_ID equals category.category_ID to retrieve products and their corresponding categories. The query for that is similar to the previous one, although this time we're pulling it by category ID. And that should actually be category_ID. I will fix the slide afterwards. Many-to-many. In a many-to-many relationship, a row in table A can have many matching rows in table B and vice versa. You create such a relationship by defining a third table that is called a junction table. The primary key of the junction table consists of the foreign key from both tables A and table B. So how do we create a many-to-many relationship? Well, a relationship that is multi-value in both directions in a many-to-many relationship, a product can have more than one vendor, and a vendor can have more than one product. So in this case, we're going to create a new table called product catalog in our database product catalog called product vendor. These are the table names of the two tables we want to cross-reference. And in this table, we're going to add product ID and vendor ID. And it's going to be a primary key of both. So this will be a composite key. And it looks like this. So we have a product vendor table that can have a one-to-many relationships of vendor and a one-to-many of product. Therefore, a product can have a many-to-many relationship with vendor and vice versa. To query that, you would need the product table, the vendor table, and the product vendor. And then you would need to match the IDs from your product to the product vendor ID and the vendor ID to the product vendor ID. Adding foreign keys to categories, these are just constraints so that if you were to add any data to these tables that have these relationships, if you tried to delete or edit them, it would also affect the relationship between like the product and category and image, or product and image, and product and vendor. So here we're adding a foreign key relationship to category. This is just based off category ID. So this was that one-to-many relationship. So it says we're adding a constraint. Our constraint name, foreign key is category ID, and we're referencing the product catalog.product to product ID. Foreign keys to an image. So this is that one-to-one. So we're just referencing the product ID from product to product ID, and we're associating that to the image product ID. And then adding foreign key relationships to vendors. So this is tying the foreign key relationship from product ID to the product ID, and also to the vendor table and the vendor ID in the product vendor table. All right. So I'm not actually going to build the catalog. I've already built it. So we're going to go take a look at what it looks like in MySQL. For those of you that do not have MySQL, you can download it at https://www.mysql.com/. Or for those of you that are looking to build an internet business, you can sign up for a free launching internet business at developer.com/launch, where we walk through setting up an Amazon cloud environment, which includes fully functional Linux, Apache, and MySQL and PHP build. So real quick here, we'll connect to my database. And in my database here, you see I have a product catalog database. Inside the product catalog, we have category, which has our columns, our ID, name, and product category. We can also click the little table icon. It's a little hard to see here. And that will throw up your little select command, which if you run, it will give you a table with all the data. Nothing's in this catalog at the moment. But if you want to actually look at the properties of the table, you can click the little wrench, and it gives you all the little details. So there's category ID, the data types, the primary key, not null, unique, auto increment, and a couple others for default as well. So I have that for category, product, product vendor. So if we were to look at the product vendor, product vendor. You see product ID and vendor ID, and the foreign key relationship is to product and a vendor ID for vendor. So let's recap. We've discussed the different types of data files, the applications which you can use to store and edit these files, such as the fixed width files, the CSV files, the Excel spreadsheet, the JSON, and the XML. We've also walked through our first steps of building our product catalog in our database, and a quick look at using MySQL. Again, you can use any database you want. The commands we provide should work, and that'll give you the base setup for your database for a product catalog. In the future, we're going to look at identifying required catalog transactions. What goes into the database? How do we want to pull information out of the database? Along with interacting with the catalog, do we want to connect it to applications? Do we want to build an interface on top of it? And reporting. Thank you for your time. I know we ran a little long today. If you have any questions or comments, send them to info@developnerd.com or just add comments on the site.